Hi, Algebra 2 students. It's Mrs. Barra. I've had some questions about section 7-8, so I thought I would just make a short video kind of getting you started on a few of these problems. The first problem that is on my screen is likely to be similar to the first one you'll encounter. So we have one person driving home from work, and this function measures their distance with time being the input, distance being the output, and then we're given another function for a different person. Time is your input, distance is your output. And then it says express the ratio of Jamela's distance from home to Eugen's distance from home as a rational function. So they are just asking you to take these two rates and put them into a fraction. A rational number is a fraction. So a rational function is a fraction. I'm going to see, give me a second here. I'm going to see if I can zoom this in a little bit. So again, this is 7-8. So we have these two functions that represent their distance over time, and they just want you to put it into a fraction. So I'm just going to take the first section and put it over the second section. That is a rational function that represents the ratio of the first person's time to the second person's. Now, of course, your answers don't look like this because you need to simplify this. So you want to think you have a fraction and a fraction. What you want to think is, what is a common denominator? Kind of think for this entire fraction. So if you look up here, my denominator is 3. The denominator under the 12 is just a 1. Here, my denominator is 8. So you want to think, what is a common denominator for 3 and 8? So that would be 24. So what I want to do is I want to multiply everything by 24. I want to clear out these fractions. And so I'm going to distribute this 24, which is a common denominator for this whole fraction. So that's how you want to simplify these. Common denominator for the whole fraction. All right, your next question, I think this is the next one. No, well, we'll jump down to, let's see. Here's the next one. So this one says, Rahim is on a road trip from Ohio to Vermont, a distance of about 700 miles. During the first T hours of his trip, his distance from Vermont is given by this function. So this is his distance from Vermont. Write a rational function that expresses the average rate of change of Rahim's distance from Vermont during the first T hours of his trip. These are the key words in this problem. Average rate of change. So when you are thinking of an average rate of change, what I want you to think of is slope. And when you think of slope, what I want you to think of is the slope formula. Oops, y2 minus y1 over x2 minus x1. That's all they're asking you for. The key word here is average rate of change. That's another word for slope. And remember, y2 minus y1 is just delta y. That's how much y is changing. And x2 minus x1 is just delta x. That's how much x is changing. So let's peek at this again. Write a rational function that expresses the average rate of change of his distance. So think again. Your input is time. Your output is distance. This function is your y. That's your output. And your input is your distance. I'm sorry, your input is your time. So it says during the first T hours, so this is your delta x, and this is your delta y. So all they're asking you for there is kind of a slope. Change in y over change in x. Okay, let's look at the third one. This one I honestly have to say I thought was a very strange problem. Seems a little bit rational to me, but rational as in a fraction, but that is your unit here. So they say Aaron and Rachel can pull the weeds in their garden in 2 hours if they work together. If Aaron works alone, it'll take him 5 hours. How long would it take Rachel if she worked alone? So here's how you want to think about this. I kind of summarized my information here. So I got Aaron and Rachel. Those are my variables. And it says if they work together, it takes them 2 hours. So you can think that if Aaron works alone, it said if he works alone, it takes him 5 hours. So this is kind of his rate that he's working. He's getting 1/5 of the job done per hour. And the question is, how long does it take Rachel if she works alone? Well, you know, if they work together, this is like A and R. So the work Aaron does together with the work Rachel does, it's going to take them 2 hours. So if you solve this, see, this is a rational function. You're going to be using fractions in all of these. If you solve this for R, that will tell you how long it takes Rachel. So again, Aaron working alone for 5 hours, you can think his rate is 1/5 of the job per hour. Okay, the last one, let me get rid of this. The last one is the salt one. I actually don't know if I opened that one. Let me go over here. I think it might be this one. Yes. So this says a 20-gallon salt water solution contains 15% salt. How much pure water must be added to get to 10% salt? All right, so I kind of, again, started to set it up for you. So they tell you you start with 15% salt. So if you have 15% of 20 gallons, that means you have 3 gallons of salt. Now, what they want is a 10% solution. So I assigned my variable to be water because I don't know what water is. So if I think that X is water, 20 plus X, so this is my 20 gallons, plus the amount of water, what I want, so this is like my solution, and I want that to be 10%. So if you distribute this 10, you're going to get 2 plus 0.1 X, and this is going to be your gallons of salt. You know how many gallons of salt you have. You have 3. So 2 plus 0.1 X is going to equal 3. And then you're going to solve that for X. So again, I didn't really use fractions to solve this. There might be another way to solve this, although I suppose percents could be written as fractions. But that should be enough to get you started on that one. All right, that is it for 7-8.